We are going to the moon, and we are going there to stay this time. That's the plan that the American government, NASA, and dozens of their international and commercial partners have made. And assuming that they can stick to that plan, what we are looking at is so much more than just landing people on the moon. Landing is not easy, but it's also not the hardest part. We have done that before. But what comes next is something entirely new. We need to build on the moon. We need to build a permanent base, essentially a small city on an alien world. And no one is exactly sure how that's going to go. But we do have some incredibly practical and innovative new solutions for life beyond the Earth. First, we need to talk about where this moon base is going to be located. The moon is a big place, and every previous human landing has happened right around the middle in a nice, flat, safe location that was very easy for direct radio communication with the Earth. But that was the 1960s, and this time when we return to the moon, we are aiming for a much more interesting location: the lunar South Pole. This region is littered with impact craters, mountain ranges, and ancient volcanoes. Some of the low valleys and crater beds are in permanent shadow. The ground hasn't seen sunlight in millions or billions of years, and it's probably full of water ice that was transported to the inner solar system on asteroids and comets. NASA has identified 13 potential landing sites for the Artemis program. They are mostly on little patches of sunlight around crater rims or the tops of low mountains surrounded by deep shadows and rough terrain. This will be a deeply fascinating region for scientific discovery, but it will be equally as dangerous for the people who need to live and work on the moon for weeks and months at a time. So this is going to require infrastructure like we've never seen before. All of the fundamentals for a city on Earth need to be recreated in the most hostile environment with the most limited resources. So where do we begin? With roads. Yes, where we're going, we do need roads and landing pads and other solid surfaces to operate and build on. The problem that needs to be solved is dust. The lunar surface is coated in a relatively thin, yet incredibly light and fluffy layer of ultrafine dust. Each grain of this moon sand is sharp and abrasive like broken glass. During the Apollo missions, it was known to cut through the outer layers of spacesuits and scratch the glass on the astronauts' helmets. To make matters worse, the dust is also clingy. Dust accumulation on the lunar roving vehicle caused it to overheat by clogging up the radiator. The trick is that without atmosphere and with very little gravity, once you kick up dust, it can really travel. When Apollo 12 landed on the moon, they tried to get as close as possible to a probe called Surveyor 3 that had already touched down on the moon a few years earlier. NASA wanted astronauts to go check in on it. And what they found was that even though the Apollo spacecraft had landed 180 meters away, Surveyor had been sandblasted by dust that the lander rocket engines had kicked up. So if we're going to build a moon base where people are constantly landing and lifting off, and driving vehicles and walking around, then we need to do as much as possible to eliminate dust from our lives. That means roads and landing pads and hard surface areas around our base camp. The quick and dirty answer in the short term could be rhino snot. That's a nickname that the U.S. military gives to a spray-on product that they use to stabilize dirt roads and helicopter landing pads out in the field. It was popular in Afghanistan for turning desert sand into solid material. They found it particularly useful for eliminating dust clouds created by helicopter takeoff and landing. So that's a potential solution for the short term. It's not ideal because we have to transport all of this rhino snot material from the Earth, and we are basically polluting the moon, filling it up with microplastics. So a more sustainable answer that can actually be scaled up to build a small city on the moon would be to just melt the surface into solid glass. This is something that the European Space Agency is working on right now with an experiment called PALA. Scientists have been using simulated moon dust and a powerful laser to experiment with melting the dust into a solid glass-like surface. This is an idea that kind of dates back to 1933 when people thought that you could pave roads through the deserts of Earth just by melting the sand. Makes sense, right? Glass is just melted sand. The idea was wildly impractical for that time and place, but in a future moon base, it might be the best option we've got. Now, we probably don't have to bring a giant laser to the moon. Instead, what we could do is set up a big magnifying glass to concentrate the sunlight. Specifically, they'd use something called a Fresnel lens. It concentrates light using grooves carved into a flat piece of clear plastic, so it eliminates the need for a big curved piece of glass. And the Fresnel lens would only need to be just under 2.5 meters wide. But given the geography of the lunar South Pole, where the sun is low on the horizon and the shadows are long, we might just need lasers as well. Either way, this would be a slow process. The Europeans working on the Pele experiment estimate that we could make a 100-square-meter landing pad with a thickness of 2 centimeters in 115 days. That is something like 100 times more slowly than paving roads with traditional asphalt. So it's a big job, but we are going to spend a lot of time driving on the moon. Our primary transportation will be pressurized rover vehicles, like this one being developed by the Japanese space program in partnership with Toyota, also known as the Lunar Cruiser. Rovers like this will be how we move around the moon base without having to constantly be getting in and out of spacesuits all day. You move directly from your pressurized habitat to your pressurized rover and then on to the next building. This is also how we explore deep into the wild. Lunar Cruiser is essentially an RV for the moon. It can support 2 astronauts on a road trip that can last for 30 days or more and would be powered by a hydrogen fuel cell. Now, having an RV is cool and all, but where do we live? Well, we need to break that down into short-term accommodation and long-term. Building a moon base is not going to happen overnight, and NASA has already designed our first lunar house. They call it the Foundation Surface Habitat. It's a 3-story structure that combines a metal frame with an inflatable module and will support up to 4 people over a time period of about 1 month. Although the Foundation will mostly be occupied by 2 astronauts, while the other 2 crew members are out exploring the moon in their pressurized vehicle. The ground level of Foundation is a metal structure that will be 4 meters in diameter. It contains the airlock and EVA suits, plus a science station for geological experiments with lunar samples. Astronauts climb a ladder to reach the second level in the inflatable module. This expands to 6.5 meters in diameter. This is also where we'll find the hygiene and exercise equipment. There's also a biology lab where astronauts will study the effects of the lunar environment on plants and animals. Going up to the 3rd level is the primary living space for the crew. There are beds, a medical station, kitchen, and computer workstation. There is also a human research lab where astronauts themselves become the guinea pigs in a study of how long-term habitation on the moon affects the human body. Now, if we can get past the foundation period, then we need to start building permanent structures on the moon, something that provides a level of protection and security. We need to insulate ourselves from the dangerous cosmic radiation, mitigate the effects of wild temperature swings between the lunar day and night. And we also need to be protected from meteorite impacts. To accomplish this, we go back to the beginning of human architecture. We build with bricks. In the same way that scientists believe we can melt the lunar surface to create glass roadways, they also think we can bake moon dust into structural bricks. The idea is that we could still use something like an inflatable habitat or even a solid metal structure, but then we encase it in a shell of brickwork. This should mitigate most of the dangers from radiation and micrometeorite impacts while providing an insulating layer to make heating and cooling the habitat more efficient. China has already begun testing their own moon bricks. Their idea is to build this egg-shaped structure called the moonpot vessel. The construction would be done by robots and incorporate traditional Chinese construction techniques with bricks made from lunar soil in addition to 3D printing. In 2024, China began an experiment to create bricks from 5 different simulated lunar soil compositions and tested 3 distinct methods for heating the soil into solid rock. Then in November, they transported those bricks to the Tiangong space station, where they were placed on an external experiment rack. The bricks will spend the next 3 years being exposed to the vacuum of space, cosmic rays, and large temperature changes to see how well they hold up. There's also this wild concept to combine glass melting and habitat construction into a giant sphere structure on the moon. This looks insane, but a U.S. company called Skyports has received funding from the NASA Institute for Advanced Concepts to develop the idea. What they do is basically just glass blowing on a large scale. You heat the moon dust until it becomes a molten goo. Then you use compressed gas to blow it up into a big sphere. Since there's no atmosphere and very little gravity, you wouldn't actually have to blow very hard, and the structure could grow to humongous sizes without collapsing on itself. Then, to add more protection and insulation, you could blow multiple layers of glass with air gaps in between, kind of like a multi-paned window. Probably not the most practical idea, but it's pretty neat. Either way, none of this is going to work without power. So where does that come from? Well, there's the sun. We all know that one. Most lunar missions to date have been mostly solar-powered, and that's worked well enough. But there's a big problem with solar energy on the moon. Because the moon rotates so much slower than the Earth, it ends up with this very long day and night cycle. 2 weeks of sun followed by 2 weeks of darkness. That was never a problem for human missions because those guys were only ever up there for 3 to 4 days tops. But when we send an autonomous lander or rover with solar power, they are only able to work for 14 days. Then they freeze solid for the next 14 days. And most of them just never turn back on once the sunlight returns. Even if they do, they don't work the way that they used to before the sun went down. Now let's flip back to our map of the 13 potential lunar landing sites. Check out all of those shadows. Most of those areas are in permanent shade. Sunlight never gets in there. And those are the locations where we are most certainly going to find the water ice that we need to sustain our moon city. So the answer is to go nuclear. Nuclear power in space is not exactly new. China has been operating a nuclear-powered rover on the far side of the moon for a few years now. NASA has been using nuclear rovers on Mars for over a decade. Their Voyager probes from the 1970s are also nuclear-powered, but these are all very small-scale operations. These generators use the heat produced by naturally decaying radioactive material and convert that into a few watts of electricity. It's fine for a robot, but you cannot scale that up to something that would power an entire lunar base. We need a nuclear power plant on the moon, and that's exactly what NASA has been working on for several years now. They call it the Fission Surface Power Project. This uses the same fission reaction that is standard at all nuclear power plants on Earth. You split atoms of uranium fuel, which release a tremendous amount of energy that manifests in the form of heat. In space, where there's no water to boil to drive a steam turbine, we can use something called a Brayton converter to turn heat into electricity. It's pretty complicated. I wouldn't worry too much about how it works. It just does. And one of the advantages to those shadowy craters that never see sunlight is that we can just put the nuclear reactor down in there and it will never overheat. The trick is that these reactors have to be small. NASA specifies that the weight needs to stay under 6 metric tons, and it can't be any bigger than an average car. For a nuclear power plant, that's incredibly tiny, but for a space system, it's still pretty big. Rolls-Royce is actually one of the companies leading the way in space-based nuclear technology. Most people probably only think they make super luxury cars, but Rolls-Royce has been manufacturing nuclear reactors for the British Navy submarines for over 60 years now, so they have a lot of experience in the field. Their current micro-reactor design is aiming to produce between 50 and 100 kilowatts of electricity, which on the high end would be enough to power a small factory or a few average houses. So just one of these would be plenty to get us started with a small moon base. And then we'd only need to stack a few of them together and we could power a moon city. So there it is, our first outpost beyond the Earth, a gateway to the solar system. If we can figure out how to not just live on the moon, but thrive and build and expand, then we've unlocked new possibilities in space that would never be possible from the Earth. This is how we boldly go where no one has gone before.